Our next speaker, delivering a talk called Delivering AI Applications with Open Source Platforms at Scale. And please help me welcome on stage. He's just about to set up his laptop. He's proof. Dimitri was here earlier on from StarTech. He said something a few years ago that, we Greeks are everywhere. You'll find a Greek everywhere. There may be in every research institution around the world. There may be,
I forgot my adapter.
5 Americans, 3 Frenchmen, 7 Chinese, but there's always one Greek, always. So, where are we? There we go. Okay, we need to put an adapter in there. Oh, there. All right, we won't be a sec. Okay, I think we're almost ready to go. So a big warm round of applause for Pantelis Monogioudis, who is from Nokia Bell Labs as Head of Applied Machine Learning Research. Welcome, Pantelis.
Okay, thank you. I'm very excited to be here. It's the first time I speak in Greece for a conference, so I'm very special thank you to the Nokia team who invited me and spoiled me. It will be a hard landing after tomorrow. The topic of today is aimed towards entrepreneurs that are present in this room or elsewhere, and I'm actually going to go through some of the ways that you can think about embedding AI into your products and services, and of course using obviously open source software. I think I'm not as old as Steve, but I've been around for a while. For the last 20 years, I have led various teams in multiple countries. Anyway, you can read the rest there. It's kind of a patents publication, a failed startup, which I'm very proud of. I teach at, in New Jersey, we don't have MIT, we have NJIT. It's a kind of a different sort of technical university. But I started teaching there computer science as of recently. And I grew up dreaming about wireless and more with emphasis on the physical layer and Mac layer kind of designs. That's how I 10 years ago, I started diversifying in machine learning. And here I am. We have 2 departments in my group. One is in Budapest, the other is in New Jersey. And we are desperately looking for some people to start a new department in Paris. If you know anyone, as we are kind of desperate, that could perhaps be trained even on machine learning, has a good degree, either a master's or PhD, and has done some things in programming, please get in touch with me. So, first slide is kind of the easy one. So I'm actually from a nautical family, as I was born in this island of Chios. I kind of use nautical analogies. So anyone can tell me what is really anything peculiar with this boat? This was in 1844 in the port of Amsterdam. Yes, Steve?
Sails under funnel.
Steve. Yes, of course. That's the thing which is, of course, the peculiar thing about it. And it's actually, the reason I'm actually using these analogies, we are very much in a very similar boat for AI today. Lots of people talk about AI and machine learning. Obviously, AI and machine learning is here today. But for the so-called mission-critical industries, and I want you to think about yourself back in 1844, boats were everything at the time. They were the main means of transportation, anything that connects. And so no one actually could trust the new technology, which was at the time the steam engine, to cross the ocean to the what is now called the United States. I want now to sort of start getting into what kind of AI we are talking about usually today. And I want to play a couple of videos, or maybe 3 videos. We'll see if it plays. So the first one, I'm supposed to have some sound here, but I'm not so sure. I guess I can enable sound from here. Is this playing? No? Okay. So this is, many, many decades ago. I don't know how many, probably 5 decades ago. People started thinking about the AI, and at the time, well, this is now actually called the good old-fashioned AI. And what you see on the video is effectively a simulator of built on Unity that shows a self-driving car kind of moving along a highway. The simulator is connected to some kind of a GPU resources, which were they're sort of executing the algorithms, and with a green line you see the waypoints which are being planned ahead, so it actually senses the environment, usually with video, LiDAR or radar, and it is sort of projecting a trajectory out of the many it could possibly go. As you can see, when it sees a car in front of it, it will actually is able to change lanes, and after a while to go back to the original kind of lane, moving along nicely the highway. And so it looks something that is something intelligent is happening there, but in fact it's basically a bunch of rules. So the vast majority of intelligence we had actually up until recently, but we still have quite a lot in mission-critical systems are rule-based systems. So the rules are actually driving the behavior of the vehicle instead of something that will actually be a bit more intelligent. And if I find my cursor, okay, so I found it. In the second kind of video, we see what really followed the good old-fashioned AI for the last 10 years, which is with us, the philosophy of connectionism. And the connectionist philosophy is, I will call it, it's called connectionism because it connects very elementary circuits called neurons. Okay, it's kind of a huge abstraction compared to a human neuron, but effectively it's a dot product followed by nonlinearity. And what you see here is you have a circuit where the car is actually driving, but what is really driving the car is a deep neural network, what Vladimir mentioned as the black box algorithm. So in that algorithm is actually receiving sensing information from the environment, video. The picture is pixelated because the deep neural networks cannot really have the throughput required to do real-time driving when they receive high definition, so we have to requantize the video. And what is really producing at the output is a steering direction, acceleration, and deceleration. So that is what is really with us today, deep neural networks that are starting to be used in sort of mission-critical tasks. And of course, these are all research sort of directions, as most self-driving cars today are still employing the good old-fashioned AI augmented with deep learning. But no one is crazy enough to allow a deep neural network to steer the car. So what is really coming in the 20s, and this is an indicative video, but there is a catch. So what's the video? This is perhaps the most advanced robotics company in the world. It's called Boston Dynamics. The name of the company is indicative of what the robot is doing, but it also has a technical aspect to it. In order for the robot to move like this and to do certain things, it has to understand, the engineers had to actually have a very good grasp of the dynamics of the robot. That's why it's called Boston Dynamics. But the catch is that there is always a human with a joystick somewhere that is not really shown in the video. So what is really unfortunately happens is that there is the human not only is able to intervene, but is actually able to make the robot do long-term decisions, something we're not really able to achieve today. So lots of things have to happen, not only long-term planning, but also causality. All these kind of concepts are actually coming into the picture. I'm sure this is green. What does the green mean? Green mean? Oh, green is fine. Okay. All right. All right. So today, I want to, since this kind of review, I want to go through a topic of an example of a mission-critical industry, probably the most critical industry, which is health, and cover sort of the introduction of AI in health and how it is actually being done today. And to some degree, it is connected with what Vladimir said about interpretability, as you will see shortly. So I want to start with a company called heartflow.com. Heart and flow, one word. You can start seeing what is really behind it and the stages of introducing AI of that company. That company is 12 years old, and it's a sizable company right now, and it's based in California. So we're going through the team, first of all, the idea behind it, the business model, the architecture of the sort of AI architecture, and the implementation of that architecture on pipelines, and of course the market validation and exit. And then after that, I'm going to go through a couple of other sectors that I believe have actually local appeal also. Okay. So I think it was 7 years ago, I also lost a friend from heart failure in New Jersey. So the statistics are very staggering. And I want you to just take one moment to just absorb those numbers. 640,000 people are dying every year in the United States alone from heart failure. That tells a lot about the way of living, but it's actually, to some degree, it is associated with stress and what you eat. That's why I'm sort of switched to a complete Mediterranean diet since I met my wife. And after spent several years trying to not to. But the other staggering number is $300 billion number, which is, okay, you can put a number behind a life, but $300 billion even for US standards, which is, I think the GDP is around 12 to $13 trillion, something like that. It's a very big number. And you will realize why it's a big number if you have something like, if you don't have health insurance and you show up at the emergency room, and then for a headache, and then after you exit the emergency room, you receive a bill for $5,000. And there are some other cases for $50,000. Basically, they can charge whatever they want. And you should really have a health insurance. Otherwise, don't visit the emergency room. So the idea, what is the idea? So that was the problem. The problem was actually very evident to anyone who is willing to go through the numbers. And the idea is to take CT scans. So people are obviously go to doctors, and the first thing, also another differentiator in the US is that doctors are making lots of tests. And to open a parenthesis here, there are 4 systems. So when I was in England in 89, I visited the doctor of the university, and the doctor had a computer, which was kind of a shocking thing for me at the time. And the computer apparently was what's it called, a teletext system. It was some archaic system anyway, but however, the computer knew that I was a new patient. I have, or after I visited once, he knew what kind of prescriptions he gave me. It was kind of an eye-opening experience for me. And I think 20 years later, well, not 20 years, but 10 years later, when I visited the US, I was expecting to see the same thing, and even more advanced. There was no computer. Everything was hand-scripted. The pharmacist couldn't read the prescription. I had to call the doctor's office to understand what on earth this doctor subscribed to me. And another doctor that if you change doctors, the second doctor will actually make the same tests that the first doctor did. Just last year when I told my cardiologist, as I was very sensitive of the topic, of course, Why on earth are you making this kind of tests? Is that it's cheaper to do the tests again rather than to ask the other hospital to send me the tests. So close parenthesis here. So the lessons learned is that you have to have some kind of local understanding of the market to get into this kind of stuff. And I'm sure some of you probably have similar experiences. So anyway, what is the idea? The idea is that since people make all these kind of tests, even just focusing on one hospital, we can actually have in their repositories probably hundreds or thousands of CT scans that they are making. And what we will do, we'll take the CT scans and make, using computational fluid dynamics, a three-dimensional model of the heart of each patient, which is, okay, fine. So why we have to do that? Well, what is the alternative? The alternative is that we have to insert a catheter through the groin. I don't want to show you the groin, but it is a sensitive part of the body. We have to insert the catheter all the way up to the heart and to measure the blood flow and understand if there is yet another procedure which is required to insert stents to open up the blocked arteries. So the cost of doing the the status quo kind of test and procedure, as I just told you, is quite expensive, probably in the tens of thousands of dollars. And the idea is to reduce the cost. So the team which has actually had to work on this kind of topic, obviously it had to include medical doctors. Don't start anything on the health without a medical doctor in your team. That's point number one. Mechanical engineers, because probably doctors don't understand computational fluid dynamics, but mechanical engineers or physicists and so on do understand them. Even electrical engineers can understand them. And of course, computer scientists, because after we do the three-dimensional model of the heart, we have to run certain algorithms to understand which artery is blocked and which other artery is okay, and where the treatment is going to be focused on. Very, very important final point, as a note, no FDA approval was required. And that's like a game-changing kind of thing that happened. So the regulatory environment is also extremely important. If you do require FDA approval, maybe the game is over right there, because it requires quite significant funding to even start this thing. So the business model, Medicare, which is the equivalent of ICA, maybe, with several asterisks, reimburses HeartFlow $1,500 approximately per test, and effectively we are saving $4,000 in costs. And the test, more importantly, is non-invasive and can be done for anyone. It can be done as a kind of a workflow system automatically almost. No one has to approve it even to actually make this kind of study. You can consider it as part of the radiologist or whoever who is interpreting those kind of scans. And most importantly, as in everything, there is this embedded base. The embedded base was called Siemens at the time, and it still is. And this embedded base means that there are Siemens and other companies, Philips and so on, have embedded base of equipment inside all these hospitals. So the tricky part was how to be part of that embedded base, and if that system was something like a closed system, so the CT scans were not accessible, etc., 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 that was another game over situation right there. Instead, Siemens itself, even Siemens, actually, I would say, started opening up their platforms in the same way as folks yesterday talked about Nokia and the telecom business. So there's opening up of the platforms created, so Siemens created marketplaces where people actually can go and host all this kind of intelligent algorithms, I will call them. And basically, Siemens takes a cut. The company who has the algorithm takes a cut. The hospital saves money. So it's really a killer business model that has a widespread, worldwide applicability in this health industry, which is probably something that some of you may start wondering if you can actually do similar things over here. So what we actually need to put this thing into some kind of implementation to make it work. First of all, we have three attributes for an AI architecture. One is really the system has to be composable. Even now, you can understand there are multiple components. There's a computational fluid dynamics model. There is machine learning models. Everything has to be stitched together in some kind of workflow, maybe airflow or something like that. We'll see shortly. Then it's extremely important to design the system to be scalable from the very beginning, because you never know. You may become someone big, and in fact, that company became fairly big. It's around $1.5 billion valuation today. And I will, when I go to market adoption, and you will understand why they have become very big very quickly. And of course, resilience. Resilience is actually extremely important because it's a mission-critical system. And you don't want the system to fail when people are effectively dying. And in fact, many people are actually going to the hospitals in a very bad condition sometimes because of the health insurance kind of problems, at least in the US. And of course, portable, you want the environment, the AI kind of architecture to be able to be supported by laptops that your developers are actually doing and writing code, to farms that you have some training rigs perhaps internally to minimize some training costs with the cloud guys, and of course various other targets. So there are maybe some specialized targets, like we have in telecom. We have, let's say, base stations. They have nowadays, they will have very shortly specialized targets like GPUs and so on to run these algorithms. The same thing happens with the so-called Siemens equipment in the hospitals. They are specialized targets that require retargeting, and therefore the whole thing has to be very portable. All right, so in order to actually build this architecture, no one is expected from you to even read this slide. I'm in the technical advisory committee of the foundation called Deep Learning Foundation. The Deep Learning Foundation is a foundation of a very well-known foundation called the Linux Foundation, which is the biggest foundation in the open source community ever. And the purpose of the Deep Learning Foundation, which is just 1 year old, is to bring together open source projects in the AI and ML space in order to create end-to-end solutions at the end of the day. Similar to what Linux Foundation is doing with Kubernetes and other networking stuff that are a bit more in the telco space. So we have effectively, the slides are actually live on GitHub, so if you click after this block, then something will pop up giving you information about each and every of these blocks. And so these are all open source projects that somehow someone, the architect usually, or an architecture team will put together into a solution and cover the gaps with their own kind of sort of source code. And another project I'm referring to is over here in this block here, the IQMOS, which is an AI project started with AT&T. It's a very big company and a customer of ours. And I'm in the technical steering committee of IQMOS. And it is basically the marketplace project. The open source project is actually giving you a marketplace. So any company could actually launch an IQMOS instance and host applications. And hopefully this is somewhat visible. First of all, why is it reverse triangle and not, why it's flipped? So up until very recently, in fact, 8 years ago, maybe 5 years ago, companies are investing in AI kind of space in a kind of a different way. They said, okay, we need to buy GPUs. We have to host these GPUs in these kind of farms, in our internal clouds. We have tailored equipment. So the enterprise data centers are very, very large, were very, very large. And now what we see is that for some industries, you don't have to do that. In fact, You can take any the business models of other well-known kind of companies which require massive scale, and you can see that themselves are adopting the public cloud providers en masse. So the line that separates the enterprise space is this one over here. I'm not sure you can see the mouse. Below that is the nowadays a small footprint of enterprise specialized equipment, as I said, training rigs perhaps, but the very large component outside of this, very large environment outside of this enterprise space is in the public cloud. And people will say, okay, this is really very expensive. We're paying Amazon and Google, you know, like 200,000 euros a month. We cannot afford them, et cetera, et cetera, et cetera. You know, if you go through all this kind of Excel spreadsheet kind of calculations, most of the time they are wrong. And in fact, you can save quite a lot of money by being agile in the public cloud. There's also the opportunity cost that most of these models do not account for. Opportunity cost means if you are late by 6 months, what will actually be the impact of your business model? So going on this kind of stack, you have, if you like, some specialized equipment in the bottom that you cannot move out of your environment. This could be, you know, medical instruments, base stations, whatever have you. And the very first layer on top of that is obviously you need to virtualize some of that with some kind of a Kubernetes, sort of abstractions. And on top of that, people have developed an open source project which is extremely important, is becoming very important. It's called Kubeflow. So Kubeflow is supporting machine learning workloads natively on Kubernetes. So it's something that you need to know and you need to start understanding, because it seems to me that it's becoming almost it will become almost a de facto standard, because everything in Kubernetes is becoming a de facto standard. And on top of the Kubeflow, which is basically executes all these kind of workflows and pipelines, we have the machine learning frameworks. So machine learning frameworks today, you know, you name it, everyone claims that they have a machine learning framework. Only 3, maybe 4 machine learning frameworks, if you include China, are appropriate for any serious kind of startup. We are a TensorFlow shop. We bet on TensorFlow early on. We never looked back, despite the PyTorch kind of love affair with the academic community. I know not only academic, but also Facebook. But if you are interested for something that actually take your model all the way from very much an idea all the way into production, I think it's very difficult to find something other than TensorFlow, especially when you start coupling that with hardware. So I think Laurent brought in, or will mention in the next talk, the TPUs, the TensorFlow processing units, and we'll actually give you an example of a just released TPU, which I also got the day before, last week, which is Edge TPU, and it's basically a Raspberry Pi able to execute TensorFlow models fairly inexpensively, meaning power-wise. I'll show you an example which requires quite significant more power on that. On top of these machine learning frameworks, we have the platforms. So we have the platforms and pipelines where public cloud providers like AWS is providing, like SageMaker, and Argo is there. Argo is effectively the pipeline technology that is behind Kubeflow. And of course, IQMOS will be also supporting pipelines or using one of those. And the most important part of the picture is the top layer. These are all the applications. These are effectively managed services for the public cloud providers. They usually work. They work like 99.99% of the time in terms of availability. Maybe that's not good enough for you, but for a good chunk of companies out there is pretty good. So there you meet the NLP applications, speech transcriptions, video recognitions, and so on. And every single public cloud provider has their own terminology. And the most important part of the whole story here is that you just open a Python notebook and you can start using the SDKs of these cloud providers, and you usually have a result very, very quickly, and you know that you can scale. All right. So the 4 pipelines are listed here usually. So Hartflow had to implement something like that in terms of functional kind of split between, the functional split of their AI architecture. So they divided the AI architecture into 4 stages. The first one is the data pipeline. The second, what it follows that is the model training pipeline. Then there is this module evaluation and validation, and then you have the serving. Okay, so for the interest of time, I'm not going to go through the details here, but some people, I think, was it Plum? I think they mentioned about the ETL stuff that they are doing in their application. In the data pipeline is extremely important pipeline, and it is where you do all the transformations needed for your raw data to actually go into something that your model trainer understands and actually can do model training. And not only that, but you have to repeat the same stages that you do in the data pipeline during serving, because you have to do exactly the same transformations in the serving part. Then you have model training that, apart from just the ordinary function of training, you have outer loops. You have hyperparameter optimization, which nowadays, I think Laurent is going to also mention about AutoML. AutoML is effectively what drives these days in the hyperparameter optimization. And I think he's referring to the Google Cloud term. Then on top of the hyperparameter optimization, you have architecture exploration. You have to try multiple neural network architectures, not only just optimized hyperparameters here. And also representation exploration, which I unfortunately don't have time to go through. Then just before you start serving your models into your AI application, you have to make sure that they do work when they hit the production. And that's the whole concept of having an evaluation and validation pipeline before serving. And this is basically the serving. In the serving pipeline, that's where you make your money or not. And it is, if you want to, definitely hear a bit more about that, just look at the TFX. This is a TensorFlow extended white paper. If you Google it, you will actually get to understand why we have each and every block and behind this kind of pipelines. So very quickly, IQMOS. IQMOS is, as I said, a project. You can see the architecture here. Obviously, I'm not going to go through. The most important part of the architecture is the the right side. It is a federated architecture, which means that various companies can actually launch an IQMOS instance and take the models that were developed by those pipelines and host them. Obviously, Hartflow didn't have to do that because Siemens did it for them. They effectively, what is really behind a solution that Siemens and other companies have, maybe something that IQMOS can actually be helpful about. All right. So what was the market reaction from Hartflow? The single most important aspect of Hartflow was that they had effectively interpretable results. So if you are in the health industry and you are addressing a doctor and you go with a black box and say, this guy has cancer, or this guy doesn't have cancer, and you say, and if the doctor says why, and you say because the model said so, then the game is also over right at that moment also, even after you spend a lot of money developing everything. So the interpretability of the predictions is extremely important in the health industry and also in some other industries as well. Obviously they didn't do a full-blown AI solution. They had the three-dimensional model. Obviously the model represented some form of reality. Just because of that, they could say, okay, the prediction is kind of matches where you can intuitively see as a stenosis right here in that artery. The scale that I mentioned a few slides earlier came when NHS, the National Health Service in England, adopted Hartflow solution across the whole hospital footprint, which is like a massive footprint. So that's why you need to scale. That's why you need to design for scale from the very beginning. So what other opportunities are there? I see significant opportunities in the surveillance kind of space. That's another kind of video. Hopefully there's no sound. This is effectively a typical surveillance video. That specific one shows the Nokia CEO when he visited our lab. And I am somewhere in the back sitting there. There are very strange dynamics when the CEO visits. And you can see a lot of people are trying to do a lot of things. That's where my boss's boss coming in. Another cluster is formed around it. They just ignore the CEO, who is just annoyed at some point. There's some noise on the back. But anyway, for those Nokia guys present here, this is kind of a funny video. The important thing about that is that in our algorithms, when they were running, despite the fact we use state-of-the-art machines and 3.4 kilowatts of power to power them, to power all the algorithms that are running around 20 to 30 cameras that we had in the lab, we were unable to fix the mirror effect. So the mirror effect is that there's a glass, and the object detection algorithm gets confused. There is a person there, as you can see. But in fact, this is a reflection of Marcus, who is the president of the labs. And I want to show you another video just to see how a 2-year-old is figuring out. Watch. So figure it out. That's fine. That's basically in 2 minutes. I'm not sure if I am playing an advertisement here. Hopefully not. Then I crash the presentation. Okay, so the other important part, and I'm finishing now in 5 minutes, is video analytics for sports. As you know, the US is very big on sports. Europe is also, and more sport than the camera. When you go into the sports analytics, you need to make sure that you have figured out an architecture, also not only the algorithmic part, but also the hardware part, where you store the data and so on. Because you are selling a sports analytics kind of system, you cannot just delete the videos. You need to keep them at least as, for the duration of a year or so, because players are changing. Have a good year, have a bad year, and so on. At least a year. So, despite the fact that the sensor architecture, the sensors are becoming very inexpensive, the cloud providers will charge you if you keep everything in the cloud. So, $3,000 to store one stream of video for a year at 720p versus $200 for a camera. We went into the sports analytics in a different way. I'll show you a video, which is probably the most fascinating video. And I'll close with that. So this guy is Alex. He's a sailor. Sailing is a very big business in Greece, or sport. He travels with this 70-foot racing boat on oceans. And what we did is we wanted to study his biometrics across the trip in order to improve his performance. We developed a special application. You can see the iPad wearing in his ear there. There's going to be a sleeve. The sleeve is developed algorithmically by my team in Budapest. And this guy is one of a kind. So we measured everything. He accepted to annotate everything for us. And we are now in the second iteration to add video. And why we're adding video? Basically, this guy sleeps for maybe 2 minutes every 15 or 20 minutes. I forgot now. Or he cannot really sleep for a long period of time if of course, there's a storm. The last time he was first, maybe 3 nautical miles just before the termination, and he just couldn't wake up. He was completely fatigued. He lost the turn. He almost crashed into an island. And so the next iteration of our effort is not just to allow him to annotate, but also to help him wake up. So that's another task that we have. All right, I think I think I have 2 more slides. Obviously, you know about the edge now. You heard a couple of presentations about the edge. I think Andrian and also another colleague of mine, Nokia. There are lots of opportunities for edge. Lots of opportunities because cloud providers are going to be shipping specialized hardware inside enterprises to cover that kind of market. So if you are in the kind of capability to put together some hardware, perhaps with GPUs and so on, you can actually start creating companies and calling Amazon and so on to see if they're interested in your solution, especially if you can minimize the latency, which is why a lot of these applications require. As I said, the video analytics that we do nowadays or in our next iteration is going to have edge TPUs or Jetson Nanos on the camera levels to actually run the algorithms very local to the camera, to the sensors, and then carry subsequent kind of processing on the data center, which is still inside the enterprise. Transportation, another very, very big opportunity, also locally. I can't think of a bigger transformation than the electrification of vehicles that we will see shortly. If you're in the market for an expensive German gasoline car, probably you want to stop buying it and wait a couple of years. In a couple of years, there will be approximately 10 electrical vehicles in the market at around $30,000 level, or even less. So, as I was going to an event in downtown Athens, I came to understand exactly what congestion means, it kind of mirrors what we see in bridges in Manhattan, but only probably worse. So there's lots of opportunities to create new revenue streams for the local government. So if you have some contacts in the local government, you can put solutions around congestion pricing. Requires a lot of mathematics around yield management, also video analytics, license plate recognition, and et cetera, et cetera, et cetera. So closing. I'm 43 seconds over my thing. For me, there is no such thing as an AI startup. You need to have a business model. The most important part of your business is really your Excel spreadsheet. And if that Excel spreadsheet is not sound, then you probably have challenges ahead. So look at your business model first, then worry about AI kind of later. And rethink mission-critical industries. A lot of industries today are around services, but not many people are actually looking around mission-critical industries and services associated with mission-critical industries. So all the sectors I mentioned here are long overdue for a huge transformation, and I hope some companies here are willing and able to capture it. And that, thank you. Yeah.
Thank you. Thank you, Pantelis. Let's take some questions, shall we? Right. Have you considered the ethical complications in autonomous cars? Who's going to choose the decision in a bad dilemma accident scenarios? I think we've heard this question before a number of times. What is your view on that?
Well, obviously there's going to be some ethical complications. The interpretability is also a very important component of addressing this. So obviously there's a classical question in autonomous vehicles of who to kill, the mother with the child on the end of the road, or the driver by sort of, so try to avoid the mother with a child at the edge of the road, or just kill the driver who made a mistake and crashing the car. So it's something that I cannot really offer more. I think interpretability is something that
sounds like a Brexit question. No one can answer it.
Yeah, probably.
Okay. Do you think FPGAs will play a major role in AI, edge or cloud, especially in the power efficiency they offer? I think you mentioned
they will play a very big role. FPGAs are programmable platforms. They have their own kind of power capability, kind of operating point compared to GPUs or even SOCs. I think what Google is doing and NVIDIA is doing by releasing this kind of low power capabilities at the edge is actually extremely important for a bit more specialized applications. Amazon is already offering FPGA instances. So if you're not really using them, go ahead and use them. They're there.
What is the role of the ML engineer in the new auto ML asterisk era?
Yeah, well, just like every single industry, you cannot really escape the normal sort of projection of someone's kind of career, right? So I'll tell you one thing. One good PhDs in the United States from well-known universities today, and this is done because of the demographics we see here. We see a bit more women today than we saw yesterday, right? But usually if you go to a major conference in the US, you see 95% men. So we shut down 50% of the population of candidates to become ML engineers. That brought up salaries to an unaffordable level. In fact, even if we can afford the salaries, we cannot have people to work on this industry. So AutoML came out of the need. A starting salary from a well-known university in the United States of a good PhD with well-known publications in well-known conferences is $250,000 a year. Okay, so who can afford that? Only probably big companies. And not surprisingly, those companies are the ones which are driving AutoML. Yeah.
Have you thought of opening Bell Labs in Athens?
Yes, we thought about it, but my salary grade is too low to make a decision. We used to have a branch here, but maybe something is happening, which
I think something is happening.
Yeah.
What is Nokia's takeaway or target from the synergy with Alex Thompson? How collected info will be used in future products or systems? Okay, so
on the Bell Labs kind of branch of Nokia is actually thinking about a lot in health. And our CEO is very supportive of our engagement in health in general. So out of that, and we used to have devices in health. We are developing devices, as I mentioned, about iBud and sleeve. Sleeve works with measuring, the return of muscles, electrical signals that the muscles generate in the body. I had another video, I didn't show it, but that's how we actually got interested into this.
And one final one, where do you see AI to be applied for telecom?
Yeah, AI is actually applied already, not AI, but ML certainly is applied today in telecom. If you see some of my publications, when we did first trials of machine learning and back in 5 years ago, and LTE, also for localization of users, and also for parameter optimization. So it's already there. ONAP, which stands for Open Networking Automation Platform, is going to host a whole bunch of AI applications inside IQMOS. So ONAP and IQMOS are connected to do that. Yeah.
Pantelis, thank you very much, everybody. Warm round of applause for. Thank you so much.